Lesson 1.4, please set up your notes and write the goal is use inverse operations to solve one-step equations, and make a column for questions and a section for conclusion. I'm going to show you an alternate way to think about solving one-step equations. We're still meeting the goal of using inverse operations, but graphically it's going to look a little bit different. It's called backtracking, so go ahead and write backtracking. And we'll head right into example 1. Example 1a, we're going to solve the equation x minus 6 equals 22. So we start with a box, which represents x, and then something happened to that x. It was subtracted by 6, and it became a new number. That new number was 22. So we backtrack and do the opposite of subtracting 6. We add 6. So 22 plus 6 is 28. So x equals 28. The standard notation for x minus 6 equals 22 is to add 6 to both sides, creating what's called a zero pair. Zero pairs get eliminated because they have no value, and x equals 28. This is called standard notation. We'll get back to standard notation, but for right now we're going to learn backtracking. Example 1b is 8x equals 88. So there was a number that's represented by that box. It was multiplied by 8, and it became 88. So we backtrack. And the opposite of multiplying by 8 is dividing by 8. 88 divided by 8 is 11. So x is equal to 11. Example, and I'll show you the standard notation is to divide both sides by 8, creating a 1 for the coefficient for x, and 88 divided by 8 is 11. So you get the same result using backtracking or standard notation. So the conclusion is to solve one-step equations, use the inverse operation or use the opposite operation. To find the missing number. Example 1c is x plus 10 is equal to negative 7. So there was a number, 10 was added to it, it became negative 7. So the opposite of adding 10 is subtracting 10, negative 7 minus 10 is equal to negative 17. Example 1d. I think we'll make the boxes a little bit bigger so they're easier to see. So x divided by 5 equals 21 is a one-step equation. So I guess we won't make the boxes bigger yet. So there was a number, it was divided by 5, and it became 21. The opposite of dividing by 5 is multiplying by 5. 5 times 21 is 105. So x is equal to 105. For example 2 and 3, I want you to take notes from the PowerPoint that's attached to the Edmodo lesson. So at this point you should stop this video and open up the PowerPoint and put examples 2 and 3 in your notes. Then you can come back and watch the rest of this video. So if you're coming back, example 2a was 11x equals 77. So the number they were looking for was 7. The opposite of multiplying by 11 is dividing by 11. 77 divided by 11 is 7. Example 2 continued. The answer to B, the equation that you need, is x plus 52 is equal to 98. There was a number, it was added by 52, and it became 98. So we subtract 52. (98) minus 52 is 46. The number was 46. Example 2c. X minus 13 equals 214. So, let me back that up a little bit. So, x minus 13 equals 214. There was a number, 13 was subtracted from it, so, and it became 214. So we add 13 to 214 and get 227. So the number was 227. For example 3, let D equal the dad's age. Let D equal the dad's age. 14 plus D is equal to 53. So there was a number, 14 was added to it, it became 53. So we do the opposite. We subtract 14. 53 minus 14 is 39. So the dad's age was 39. And there should be a 39 right here.